This is question 9 from chapter 5D of the Year 12 Maths Quest textbook. It says that the temperature of a freezer is a constant -6 degrees. A tray of water that is 12 degrees Celsius is placed in the freezer and its temperature drops by 4 degrees in 1 minute. First of all, we've got to find the time taken for the tray of water to reach freezing point. So first of all, we know that with Newton's law of cooling, that the rate of change of the temperature is equal to it's proportional to the change or the temperature difference between the temperature and the surrounding temperature. So that's Kt minus Ts. We're told the surrounding temperature, so the surrounding temperature was -6 degrees. So that's going to give us dt is equal to Kt, take away -6, so that's going to become a positive. So we need to integrate now, but because we've got temperature over here, we can't integrate that with respect to time, so we're going to flip top and bottom. Right, it's hard to see, my pen's going flat here again. So I'll write t plus 6 this time because we've changed that sign. Okay, so we need to integrate that. So that's going to give us that time is equal to the integral of 1 over Kt plus 6, and we're integrating that with respect to temperature. So now, because we've got the 1 over t here, that's going to become a log function. So the 1 over k is simply a constant that we can leave at the front, and we'll have log t plus 6 plus our constant c. Next thing we need to do, we need to work out what the value of the constant is. So we're told that the temperature is equal to 12 degrees when the time is equal to 0. So we can put those in. So that time is 0, temperature is 12 plus 6. So we get that up, so plus c. So c is going to be equal to -1 over k log 18. So we can now go and say that the time is equal to 1 over k log t plus 6 minus 1 over k log 18. Now I can use my rule that log a minus log b is equal to log a over b. So I'm going to write that now as t is equal to 1 over k, because both the terms have k, and log t plus 6 over 18. So the next step is going to be to find out what the value of k is. So we're told that when time is equal to 1, that the temperature had dropped, lost it now, dropped by 4 degrees in 1 minute. So in that case, if it's dropped by 4 degrees, the temperature is going to be 12 take away 4, that will be equal to 8 degrees Celsius. So we can now say that 1 is equal to 1 over k log, plug in our value 8, so k is going to end up being 0.251314 with a negative sign. So now we can say that t is equal to 1 over this log t plus 6 over 18. Now the first part of the question asks us to find the time to get to 0 degrees Celsius. So that's going to give us our value for t. So t for time put our value for t, which is just 0. And when we work that out on the calculator, we get that's equal to 4.37 minutes. If we change that to minutes and seconds, we get 4 minutes. The decimal is 37. If we multiply that by 60, that gives us 22 seconds. So that's the answer to part A of the question. For part B, it asks us that find the temperature at any time t, and find the temperature after 6 minutes. So we're going to need to rearrange our equation. So we've got at the moment negative 0.2125314. So where I've got that from, I've just gone to my equation up here, and I've just rearranged that by multiplying both sides by the value for k. Now what we can do is we can do the inverse of the log here so that we get the temperature term by itself. So that's going to give us the exponential here. Now we just need to rearrange this so that we get the t by itself. So multiplying both sides by 18, and draw a bit of a column here. So we're going to have 18 e to the minus 0.25134t is equal to t plus 6. So now our temperature is going to be equal to 18 e to value for k. And now we've got to take away the 6. So now we wanted to know what the temperature was after 6 minutes. So we need to put little t is equal to 6. So that will give us our temperature is equal to 18e minus kt. And so I left the 2 off there. And when we work that out, that works out to be negative 2 degrees Celsius. And that's the end of that question.